Good morning. How are you? I'm doing pretty well. Thanks for asking. Hey, let's do thermal energy lesson 1.4. I had a visitor drop in, just a momentary pause. Let me share my screen. I'm checking out the content on my new YouTube channel, and I just uploaded 1.3. Of course, all of these videos are made for kids. Don't really like using that word kids because that reminds me of baby goats. And I don't hang out with baby goats, although I have before and it was fun. Let me clear and optimize, and let's begin. We left off at lesson 1.3 on my screen. So let's go back to thermal energy, which if you're looking for thermal energy, you can find it by going to Amplify Science. So let's go back to our home page. Remember, the simulator is in the pull-down menu, but it's also linked down here. Here's the logo we're looking for because brr, it's cold outside. And we're in chapter 1. We're doing lesson 4, molecules and temperature. Let's check our lesson briefs quickly. We have 2 key concepts or slides to show. Temperature is a measure of the average speed of the molecules of a thing. Okay, well, what's a thing? Well, as Zippy sits behind me, he knows things about stuff. A thing is one piece of stuff. Okay, I think that means matter, right? When we classify what is matter made of, the first thing we come up with is molecules, and then realize, oh, there's even smaller things than that. But when we look at molecules and go to the molecular scale, and we look at the energy that each of these molecules contain, remember that molecules aren't energy. They just hold energy. And the more energy they hold, the more they vibrate. The more energy you put into an object, a thing, the more you vibrate these molecules. And as they vibrate faster, it increases the temperature. So this may be different than what you've known temperature to be, but think about what temperature is. How cold is it outside? Well, this morning it was 8 degrees Fahrenheit. That was below 0 Celsius and or centigrade. So it's a comparison. Right now, this time of day, it's probably in the upper 30s. So just in a short time from the morning to lunchtime, we've had temperature that's gone from below freezing of water to above freezing of water. And it's basically a comparison. We'll learn something we learned something yesterday about the idea of absolute zero. And that is when the speed of the molecule vibration or movement drops to 0 and the molecule doesn't move. It doesn't even vibrate. And we learned that that was minus 200 and something below 0 centigrade. And here's the article here. Everything else looks pretty much the same, so let's get started. Our warm-up is asking us to revisit the absolute zero article and use the text to answer questions about temperature. So I think this can be opened if we need to, but it says read the following quote from the article. So they're giving us the reading material and answer the questions below. So here's the quote. This is because temperature is a measure of average molecular movement, and there is a limit to how slowly something can move. After all, if something slows down completely, it just stops. So, is there a limit to how cold things can get? Well, yeah. Explain your answer using evidence from the article. Let's take that as our quote and say, there is a limit to how cold, which means temperature, because that's how we measure the speed and the amount of energy. There is a limit to how cold an object can get. Since temperature is a measure of molecular movement, let's say it's an average measure of molecular movement, because as we see from the sim, we'll see things heat up sooner at one end than the other. And so the molecules are all kind of moving at a different speed. If one end of the object is at 100 degrees and the other end of the object is at 50 degrees, then there's going to be changes in that molecular movement. Since temperature is an average measure of molecular movement, when the movement stops, there can be no speed, which means that the measure of the speed must be 0. And let's do this. From the article, quotation mark, after all, if something slows down completely, it just stops moving. So there is the evidence from the article. And guys and girls, evidence is something that got us into the situation that we were in as a country last week, because so many people were believing things that just had no evidence to support the things they were believing. And so they were making mistakes based on lack of evidence. Remember, evidence is something you can point to and say, yes, it says it right here. And these articles come from the Lawrence Hall of Science in Berkeley, California. It's part of the University of California. And so all of this information has been verified by people who are experts in this field. Let's go to our next activity. Redefining temperature. Students are formally introduced to a new definition of temperature that uses the idea of an average. So what does the article absolute zero tell us about what temperature really means? After we talk about this, if your ideas have changed, revise your answer below. Aha, so it got this information from somewhere else. It just came from the warm-up. There is a limit to how cold temperature of an object can get. Since temperature is an average measure of molecular movement, when the movement stops, there can be no speed. Because speed is a measure of movement, right? So we're not going to change that. So an average. In science, we use math. In fact, math is the language of science. So let's put on our math thinking caps and examine this idea of an average. It's a number that summarizes a set of data that can be computed by adding all the numbers in a list and then dividing by the number of numbers in the list. We call that in math class the mean. So how would you do this? Well, you add up all the numbers. And so 4 plus 5 is 9, plus 1, 2, 3 more makes 12. And then how many numbers are there that we added? We added a 4 plus a 5 plus a 3. There are 3 numbers that we added together. And so if we take that 12 and we divide it by the 3 numbers that we added together, we get a 4. Now, I bet you've heard that before, and this is the kind of math, and this is as hard as the math will get in this class for this unit, okay? So below are 2 diagrams that show things made of molecules moving at different speeds. Calculate the average speed of the molecules in diagram 1 and diagram 2 by adding the numbers together and dividing by the number of molecules in the diagram. Be sure to show your work, and when you're finished, answer the questions below. Well, the average speed of the molecules in diagram 1, okay, so we have this diagram, and we see if we add across, we see we have a 1, 2, 3, 4, and a 5. And in the second row, we have a 1, a 2, a 3, a 4, and a 5. So I could add the 1 to the 2, or I'm sorry, the 1 to the 5, which would give me 6. And then I could add the 2 to the 4, which would give me 6. And 6 plus 6 is 12, which makes plus 3 equal 15. So the top row would be 15. The bottom row would be 5 plus 1 is 6. Plus 5 is 11, plus 4 is 15. 15 plus 15 is 30. And 30 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is a 3. The average speed of the molecules in diagram 2 is 3, 3, 3, 3, 3, 3. Add those 3 all together, that's 3, 6, 9, 12, 15, 18, divide by 6 molecules, which are what these circles represent at the moment. 18 divided by 6 is a 3. What can you tell about the temperature of the things in these diagrams by calculating the average speed of the molecules? The thing in diagram 1 has a higher temperature? No. The thing in diagram 2 has a higher temperature? No. They both have a 3. So they have the same temperature. Now we've gone through all 3. We'll hand in and move forward. Modeling differences in temperature. So a modeling tool. Students create molecular models that show the difference between warmer and cooler air inside Riverdale School. Create a model that shows the difference between warmer air and cooler air. So what we have here is a piece of paper. Let me grab that piece of paper. I'll be right back. I got it. So here's what I have. And I believe you can find this, well, no, in your digital resources. And I take that back. I don't believe that. Anyway, I show warmer air and colder air. And you can see that this diagram, I have these two blocks that seem unfinished. And then I have a key down here and a key down here. And so colder air would show a low temperature, and here's the icon for low temperature. And then the warmer air would show a higher temperature. And so this represents the air in the school. So the only thing left to provide are these icons, which would be slower molecules and faster molecules. So what are your ideas? Where would I put that slower molecule? To the left or to the right? Where would I put the faster molecules? So think about that, guys. I will use telepathy, and I will think of what you're thinking, and I will follow along with what I'm picking up in my mind, you doing as you supply these molecule icons into this model. So I'm moving on to the second portion. And this is what I picked up. This is what you told me to draw. Pretty cool, huh? So as you can see, the warmer thermometer indicating high is not really, we call it temperature, but what is it really? It's measuring the speed of the molecules. Pretty cool. A different way to think about temperature. Let's continue on. I don't believe there was a hand in button for this part. And I don't believe that you have this in your digital resources. No worries, because we're moving on. That was part 3. And we followed along with those suggestions. Students discuss the two heating systems and consider how their molecules are similar. Below are 2 diagrams showing the proposed heating systems being considered by the principal of Riverdale School. That was the video we saw a couple of lessons ago. Based on what you know so far, answer the questions below. Remember, the morning air is about 51 degrees Fahrenheit, just so that you can imagine what the thermostat in your house would look like if that were set to 51. The water comes in at 49 or is heated every day up to 39 degrees Celsius and is pumped through these pipes. The pipes then heat the air in the school as the pipe meanders through all the rooms of the school, and then that's put back in to the tank to use the next day. In this system, it's very similar. However, the water is not as warm. What this means is that because this has a lower temperature, it means the molecules in this tank aren't moving as fast as the molecules in this tank. This tank also contains a lot more molecules. Consider the molecules in the 2 proposed systems. How are they the same and how are they different? The molecules in both systems are come in 2 types. We have water and air. Each type has its own temperature that may differ from each other. Okay, so the air molecules move slower and have a lower temperature than the water. And one system has warmer water with a smaller tank, and the other has cooler water with a larger tank. At this point, which one do you think? The water heater system or the groundwater system? Okay, I'll let you decide that. Hit the hand in button when you're done, and we'll move to the homework. Students revisit and revise 2 statements from the anticipation guide. Remember the anticipation guide. These are things you agreed or disagreed. So we're about to visit these and see what we can do. Below are 2 statements from the anticipation guide that you completed at the beginning of this chapter. Look back at each statement and decide whether you agree or disagree with it at this point. Then try revising each statement to make it more complete or correct. Okay? Temperature is a measure of how hot or cold something is. Well, we know that temperature is the average speed of the molecules of a thing. Okay, that was a key concept from this morning. Yeah, the last lesson, I believe. When something heats up, it moves faster, and when it cools down, it moves slower. I agree. How could you revise this statement to be more complete or correct? Okay, I agree. By saying when something heats up, it has a higher temperature. And when something cools down, its temperature. Now you see why I take my time saying that word, because it helps me spell it. It's not temperature or temperature, it's temperature. There's an A in there. Its temperature decreases. I believe this is it. Yes. So we will hand in. Thank you for reviewing these ideas and coming up with new definitions for temperature and examining that idea of absolute zero, a very interesting idea. Is there an actual place in the universe that is that cold, where there is no movement of any molecules? This part is optional and not assigned. If you followed me so far, then you are exactly where you need to be. I'll stop sharing, and I will wish you a good day. Take care. I'll see you soon.